So here we go, chapter 2, looking at science. Remember in the first chapter I was asking you, what is science? Can you give me a definition for science? Most people think of science as this body of knowledge or this group of facts that they have to learn in school. Where science is actually a process, and a process that we use to investigate the natural world. The book puts it, science seeks to reduce the apparent complexity of our world to general principles, which then can be used to make predictions, solve problems, or provide new insight. Now, this process has different steps. Do you remember all the steps to the scientific method? So here it is, the steps of the scientific method. I have a nice flow chart to represent this. First up, in the scientific method, you make an observation. You see something out there. Then from that observation, you ask yourself a question. Why am I seeing what I'm seeing? What is the reason for this? And then from that question, you can form what is known as a hypothesis. And a hypothesis is an educated guess or statement to why something is occurring. So I could come up with a hypothesis based on an observation that I see quite often. And I could say that students are sleepy because school starts so early. And then from my hypothesis, I could then make predictions. I could predict if school starts so early, then I'll see more sleepy students. Or if I started school later, then I would see less sleepy students. So from my hypothesis and my predictions, I now can conduct an experiment. I can count the number of sleepy students in my classroom if I start it at different times. So then based on my data that I've collected from my experiment, I can then accept my hypothesis if I notice that there are more sleepy students in my classroom earlier times than later, or I might reject it, seeing that third period I actually have more sleepy students. Now, once scientists gather up enough data or evidence to why something is occurring, they like to organize or categorize their data. And two ways that they do this is either inductive reasoning or deductive reasoning. Now, inductive reasoning is where you induce, where you try to unify or bring together based on similarities. And it's the basis of modern experimental science. Or deductive, or deduce, is where you go from very general to specific. So you take away certain aspects of it. Now, deductive reasoning doesn't bring any new knowledge to the table, but it can make relationships among data more apparent. Here's an example. Tell me which one do you think this is. Do you think it's deductive or inductive? General rule. All birds have wings. A specific example. Robins are birds. Conclusion. All robins have wings. Do you think this is inductive or deductive? If you said deductive, you're correct. Let's try another one. Fact. Gold is a metal that is heavier than water. Fact. Iron is a metal that is heavier than water. Conclusion. All metals are heavier than water. Do you think this is deductive or inductive? If you said inductive, you're correct. So once you set up your experiment, you have to test whether something is causing something else to occur. And those some things are your variables. You will have an independent variable and a dependent variable. Now I'm going to draw a graph down below because once you gather all your data, you're going to have to graph it based on the independent and dependent variables. So based on my graph down here, where is my x and y? If you set your x down here and your y up here, you're correct. Now where is my independent variable? Now your independent variable is the one that you're manipulating. And yes, the independent is on the x, and one way to remember this is manipulative independent x. So that leaves us with y being the dependent. And another way to remember this is dependent is the one that responds and is on your y. So if you've heard that before, dry mix, way to represent this. So when I say manipulated, it's the one that I am saying these are the different variables. This is the different changes. So say we're looking at the temperature over 7 days. So that is the one I'm going to say day 1, day 2, day 3, 4, 5, 6, 7. Alright? My graph extended. 7 days. So that's the one I've manipulated. Now the responding one is the one that's going to change. It's the one, whatever the temperature might be on those different days. There we go. Now when you're testing, you want to set up a control. And a control is a variable that you know will not change. It's natural, or it's not something that changes. So in your experiment, when you test your first variable against the other one, you know that it is that something that is causing the other thing to respond. And that within your control, you shouldn't see it respond because it should stay the same. Last but not least, looking at scientific theory versus scientific law. Well, first up, I want to look at theory. What is the difference between a theory and a scientific theory? Well, if I have a theory that it's going to rain today, how is that different than a scientific theory? Well, scientific theory is something that is backed by tons of evidence, a lot of data, a lot of hypotheses that have been tested and not yet rejected. Where just as my theory that it's going to rain today is just an idea that I have that I think it might rain, not supported by evidence. And a scientific theory versus a scientific law, scientific theory is a body of hypotheses that have not yet been rejected, whereas scientific law is the description of the scientific theories.